In this video, we're going to look at how to find reference angles. Reference angles are going to play a big part moving forward as we move into learning the unit circle. So the definition of a reference angle is the acute angle. Remember, acute means less than 90 degrees, formed by an angle's terminal side and the x-axis. Okay, so I'm going to color coordinate my notes. I'm going to do my angles in blue, and then I'm going to draw the reference angles in pink. All right, remember my angles start on the positive side of the x-axis. If I'm given an angle in quadrant 1, so let's say this is my angle. This is the terminal side of my angle. And then here's my x-axis. So there's two types of angles I can find. I could find this angle over here going from my terminal side to the x-axis, or this angle going from the terminal side to the x-axis. But remember, we want an acute angle. Acute's less than 90, so you always want to go to which side of the x-axis is closer. So when you're in quadrant 1, what's neat about quadrant 1 is the angle you're given is its own reference angle. Because if I find the angle between its terminal side and the closest side of the x-axis, it turns out to be the angle I was given to begin with. Okay, so our angle we're going to call theta, and our reference angle we're going to call theta prime. So if you're in quadrant 1, the angle you're given is the reference angle. All right, let's say you're given an angle in quadrant 2. So this is the angle I'm given, something greater than 90 degrees. But now this side of the x-axis is closer to my terminal side. So now my reference angle is here. Okay, so the way that we're going to find that, if we're in quadrant 2, and we want to find this small angle here, we're going to take 180 degrees, or pi, whichever one you're dealing with, radians or degrees, and we're going to subtract the angle that we're given. That'll give us this difference right here. So it's either going to be theta prime is 180 degrees minus theta, or pi minus theta will give you your reference angle. Now let's look at an angle in quadrant 3. If we're in quadrant 3, we start here, we go all the way around to quadrant 3. So here's our angle, that's our theta. Forgot to label my theta in the last one. All right, our theta prime. The closest side of the x-axis is the left side, not the right side. So this right here is theta prime. All right, so if we're in quadrant 3 and we want to find theta prime, our reference angle, the easiest way to find that difference right there is to take the angle you're given, which is your theta, and subtract either 180 degrees or pi from it, and you'll get this little bit that's left over. So theta minus 180 degrees, or theta minus pi. And now let's look at quadrant 4. If we're in quadrant 4, we start here at 0, we go all the way around, and we're over here in quadrant 4. So this is theta. Well, now the closest side of the x-axis is the right side again, so theta prime is this angle right here. All right, so to find that, since the closest side of our x-axis is over here now, we're going to use either 360 degrees or 2 pi, and we're going to subtract the angle we were given, theta, and that'll give us this difference right here. So to get theta prime, we're going to do 360 minus theta, or 2 pi minus theta. All right, so let's practice finding some reference angles. For number 1, we're given the angle 98 degrees. All right, 98 degrees. Remember, 90 degrees is straight up, so that means we've gone through the 90-degree mark and we're over here in quadrant 2. So to find the reference angle, if you're in quadrant 2, you're going to do 180 minus your theta. So theta prime is going to be 180 degrees minus theta, which was 98 degrees. So 180 minus 98 gives us 82 degrees. Number 2, 390 degrees. Now that's bigger than 360, so remember we like to think of our angles being between 0 and 360 or between 0 and 2 pi. So what I would do first is I would subtract 360 from that, subtract a full revolution to get the coterminal angle, which is 30. Okay, so 30 is the angle we really want to think about. 30 is in quadrant 1. We haven't reached 90 yet, so 30 is in quadrant 1. Remember, if you're in quadrant 1, your reference angle is itself. So our reference angle is 30 degrees. All right, for number 3, negative 114 degrees. I'm going to go ahead and add a revolution to that to see what it is as a positive angle. So negative 114 plus 360 gives us 246 degrees. Okay, so 246 takes us through 90, through 180, but not quite to 270 yet. So 246 is over here in quadrant 3. All right, if we're in quadrant 3, we want to find our reference angle by doing theta minus 180. So our theta prime is going to be 246 minus 180. 246 minus 180 is going to give us 66 degrees as a reference angle. All right, now we're switching to radians. Okay, our first angle is 3 pi fourths. So remember, kind of ignore the pi, think of it as 3/4. Remember that this is 0 pi, this is 1/2 pi, this is 1 pi, this is 3/2 pi, and this is 2 pi. So if we're at 3/4 pi, we're greater than 1/2, but we're not quite at a whole yet, so we're over here in quadrant 2. All right, so for quadrant 2, we want to do pi minus theta. So we're going to do pi minus, and our theta was 3 pi fourths. All right, when you type that in the calculator, remember that since they both have a pi in them, leave the pi out and you'll type 1 minus 3/4. And we know that 1 minus 3/4 is going to give us 1/4. But if you're doing it in the calculator, you get 0.25. You'll change it to a fraction. Put the pi back with it. So pi fourths is the reference angle. Number 5, 8 pi fifths. All right, ignore the pi for a second. 8 over 5 is 1.6. Okay, so 1.6 is bigger than a half, bigger than a whole, and bigger than 1.5. 1.5 would be 1.5, and we're at 1.6, so we're all the way over here in quadrant 4. So for a quadrant 4 angle, we want to do 2 pi minus theta. So for theta prime, we're going to do 2 pi minus the 8 pi fifths that we're given. So in the calculator, you would type 2 minus 8 fifths. Change that to a fraction, and you get 2 fifths. So 2 pi fifths is the reference angle. All right, number 6. Our angle, or our theta, is negative 5 pi sevenths. All right, let's go ahead and get that as a positive angle. Positive angles are easier to deal with, so we're going to add a revolution. A revolution is 2 pi. All right, so we have negative 5 sevenths. We're going to add 2 to that. Change that to a fraction. It gives us 9 sevenths. So 9 pi sevenths is our angle, is our theta. All right, if we start at 0, 9 sevenths is greater than a half. 9 sevenths is also greater than a whole, because 7 sevenths would be a whole. So we're past that. Have we reached 3/2 yet? 9 divided by 7 is only 1.28 or 1.29. this would have to be 1.5 to be at 3 halves. So we're in quadrant 3. Okay, if we're in quadrant 3, we want to do theta minus pi. So to get theta prime, our theta is 9 pi sevenths, and we want to take away 1 pi. So when you type that in your calculator, you're doing 9 sevenths minus 1, and change that to a fraction, and you get 2 sevenths. So 2 pi sevenths is the reference angle. Okay, and the last one just says -6. I don't see a degree symbol, so that's still in radian form. All right, we want to go ahead and make that a positive angle, so we're going to add a revolution to it. So -6 plus, and this time we're going to put the pi in because it was already included in the -6. All right, so I'm getting 0.28. All right, so if we're looking for theta prime, or looking at what quadrant we're in, 0.28 would be in quadrant 1, because remember that pi halves is 1.57. So 0.28 has not even reached pi halves yet, so we're in quadrant 1. Remember, if you're in quadrant 1, it's its own reference angle, so theta prime is theta, which was 0.28. One thing I want to mention also about reference angles is they are never negative. So if you're doing a reference angle problem and you get a negative answer, you very well could have subtracted in the wrong order. For example, right here, if I did pi minus theta instead of theta minus pi, I would get the right numerical answer, but I would have the wrong sign on it. So always make sure you're subtracting large minus small. Same thing here. If I did theta minus pi rather than pi minus theta, or with degrees as well, I could get the right answer but the wrong sign. So when you're doing reference angles, you always want to subtract whatever's larger minus whatever's smaller so that your answer stays positive.